Alright, it is time again for the Catlike coding. Uh, let's see how it goes. What do we have here? Let's just press play here. Good, we have a single stream. We have an advanced mesh. And we have a simple mesh. Good, so that's how it looks. Beautiful. But I think we're trying something different now. Procedural mesh. If we press play, gonna get a mesh here, but that's what we're working on currently. Good, procedural mesh. There we go. Wonderful. So, how does this work? We're just going to follow the tutorial here a little bit, to the end probably. And why are we doing this? This is all for making a voxel game. There's some tutorials there that are helping out with the voxel game, but this here goes in depth. Go to catlikecoding.com. I can only recommend, and we're gonna see how it goes. This is where we have been before. Good. Generate mesh. Right. There's a mesh job and a square grid and a single stream. Wait a minute. Yeah, I think this is what we were writing here. Yeah, good. Let's generate a quad then. Empty mesh is generated. Yep, procedure mesh. We get an empty mesh because our job doesn't do anything yet. Currently the job isn't scheduled at all because its length is 0. We activate the job by making a square grid job length return 1. Oh yeah? So this equals and then the error symbol, the greater than symbol forming an arrow. I think this is just 2 parentheses and inside a return, and this is the return. Something like that. Good. Public int job length. Where do we have this? Good. In the mesh job? Possibly. I don't know. Generate mesh. Square grid. There we go. Job length 1. Alright, so what does this do? This causes our job to get scheduled, but when entering play mode, we now get an invalid operation exception complaining that 2 containers might be the same thing. This refers to the 2 native arrays of single stream. Single stream. Oops. Save this here. Single stream. Good. Unity complains there might be aliasing, which means that the native arrays might represent overlapping data. The reason for this is that all the mesh data is a single unmanaged block of memory. Our job tries to access 2 subsections of this data, the vertex part and the triangle index part, at the same time, and Unity disallows this because it might produce faulty results. In general, Unity safety checks are valid and should be heeded, but in this case, no. We are certain that the vertex and index data never overlap, so we'll disable the safety by attaching the native disable container safe restriction attribute from the Unity collections level unsafe namespace to both the native array fields. Easy peasy. Good. Unity collections, Unity mathematics, Unity collections low level stuff, native disable container restriction on top of the 2 streams that we have. Good. Bum 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 bum. Bum bum bum. Native array stream. Good. And native array triangles. The 3-dimensional integer type. Good. To test our framework, we'll have square grid to generate only a single quad for now, exactly like the one that we generated in the previous tutorial. So this vertex count has to become 4. Public int vertex count. Good, we need 4 vertices. In execute, in here, Good. Begin by creating a generic vertex value. Good. And settings its normal and tangent vector, which are the same for all vertices. As all values are initialized to 0, we can suffice with setting only the non-zero components. Thus, the normal z component becomes -1, and tangent xw components become 1 and -1. Test this. Of course. Of course, why even mention? Alright. How does the assignment to xw... That's what I was wondering. How does the assignment to xw work? This is a swizzle operation, which allows us to assign to a subset of the vector's components in the order that we want. A swizzle operation can also be used to extract a subset of the components in whatever order we like, and even with a repetition. For example, instead of xy, we could also access yx, zy, xx, xxy, cxxy, etc. The mathematics types implement these via our properties. Good. We can then set the first vertex with index 0. We ignore the index passed to execute method because we generate the entire quad at once. We can do this because we disable the safety restriction for the native arrays. That's good news. Alright, let's make it happen. Streams set vertex 0 vertex. Good. Don't we need the native attribute to write it to any index? Yes, but the native restriction attribute disables all restrictions, so we don't need to also apply native disable parallel for restrictions. Good. Complete the quad by adjusting the positions and texture coordinates and setting the other 3 vertices. Good. Then set the other vertices then. Streams set vertex. Streams set vertex down here. Good. Set vertex 0 is a vertex. Vertex position is the new vertex there. Vertex. I think we made this. This struct here, vertex we made, I think. Good, set vertex this. Set vertex the same. Oh, and it's not gonna reference. This is where the copying happens of the struct. Probably. We're copying the vertex. Good, this makes sense to me. We also need 2 triangles, so set the index count to 6. Sure, public int index count. 2 triangles at the index count to 6. Alright, the index count is responsible for the triangles, apparently. Then set the 2 triangles at the end of execute. Good, execute as this. I don't know how this works. I have no idea. Type S. Don't know what that means. We're just gonna follow along and watch the magic happen. Good, set triangle. In the streams. Streams, sure. Good. This should produce a quad, but instead we get an argument exception. Even before the jobs are scheduled. It happens when the submesh is set in single stream setup. When we invoke set submesh, it immediately validates the triangle indices and recalculates the balance. This is virtually guaranteed to fail, because at this point the job hasn't run yet, so the index buffer contains arbitrary data. We must apply mesh update flags to indicate that set submesh should not do anything with the data. We already used don't recalculate bounds in the previous tutorial. This time, we also have to use don't validate indices. We apply both by merging the flags with a binary OR operator. Good. Mesh data set submesh. Where is this? Mesh data set submesh. Here. Mesh data. New submesh. Where's this go, man? I have no idea. Set submesh. Find in all current. Find in all opened. Single stream here. Good, line 38. Good. Alright, sure. Why not? Index count. And then joink. Mesh update with on regular bounds or... Oh, this is complicated. This is extremely complicated. But alright, let's take the word for it. Quad generated via job. Is it? Does it work? Dun, dun, dun. Let's press the play button. And it does work. Compared to the other thingies, is identical. Good. So much for that. Wonderful. Quad generated via job. Bounds. The only thing that our mesh still lacks is valid bounds. The generator should provide these bounds, so add a property to get them to the iMesh generator interface. Oh, jeez. To get them to the iMesh generator interface. iMesh generator. Good. Here? bounds, get. Maybe. Then add the implementation to square grid. Good. But where to put this? Right in the top? Possibly. Bounds, get. That can't be right. And add the implementation to square grid. There's no way this will work. Good. Public projects. There's no way it's gonna throw an error here somewhat. How is this working? Good. To set the bounds, add a parameter for the mesh to mesh job. Schedule parallel. To mesh job schedule parallel. Here. Job handle schedule parallel. Good. I make it the first parameter. We can then set the mesh bounds immediately after creating the schedule parallel. So we're missing this there, a mesh. And then we can set the bounds here. Good. Pass along the mesh and procedural mesh generate mesh. Sure. Dum. Generate mesh. Schedule parallel. Mesh data, default. We should also set the bounds of the submesh. To make this possible, we add the bounds as a second parameter to iMesh stream setup. Mm-hmm. Amish streams setup. Of course. Where again? Behind the mesh data. Easy peasy. Good. Adjusting a stream setup so it sets the bounds and vertex count of the submesh. Single stream setup. Also, why is this not saved? Single stream setup. Here. Good, we got bounds we need to add. Behind the mesh data. Adjusting the stream setup so it sets the bounds and vertex count of the submesh. Wait. This was somewhere else. iMesh streams. This was the iMesh stream setup. Good, but we have this. Void setup. We have this. Good. And then a single stream setup. Like so. Mesh data set submesh bounds. New submesh. Index count. Where do we have it? Here. Alright. Boom. This was wrong. Good, and it's before that comma and after the index count. Squish it in here. Terrible. How is this readable at all? It is not. It's definitely not readable. I can't read it. I don't know what this does. Good. Finally, include the bounds when setting up the streams in mesh job scheduled parallel. Good. Schedule parallel. We could either store the bounds in a variable or directly use the result of the mesh bounds assignment expression as an argument for setup. I do the latter to demonstrate this usage. Alright. Good. New mesh job GS. Good. And then we have mesh bounds here. Job generator bounds. Good, instead of that, we have something after the mesh data here. Mesh bounds job put it up. Mesh bounds job generator bounds. Good, and then these things. Instead of that. That is the same. Mesh bounds, job generator bounds, or mesh bounds equal job generator bounds. This is exactly the same. But it's in the setup this time. Instead of an argument. That's great. New mesh job, job stream setup. All this stuff. Good. Right, 16-bit indices. Wait a minute, does it throw an error? No. Good. In the previous tutorial, we reduced the triangle indices from 32-bit to 16-bit because that halves the size of the index buffer. This is the same for our framework as well. A convenient way to do this is by defining a triangle uint16 type in the procedural measure streams namespace. It's a sequential struct containing 3 ushort values. Give it an implicit conversion operator from int3 to triangle uint16. Alright. Good. Let's say simple. This is by defining a triangular type in the procedural measure streams namespace. Good. But where to put it? Do we have this here somewhere? I think they want me to make a C# script called triangle uint16. Could be, right? Probably. Triangle uint16. But where? What subfolder? In the streams. So what was the name again? Triangle uint16. Create C#. Triangle uint16. It's a U integer, that's what it is. Good, and whoop. That's how it looks. See if it complains. No, we have this type defined now. It's a struct. And it has in it A, B, and C. It's probably for a triangle. And it has U shorts in it. Just to make this very small. Because it doesn't need to be big. Is this a short? Could this not be bytes? Wouldn't bytes be even shorter? I have no idea. I do not know what I'm talking about. Now we can switch single stream to 16-bit indices simply by changing the triangle index element types and the index buffer format. Easy. Single stream. Good. Bum 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 bum. Native array and triangles. This is not an int3 because that's too big. We made our own type here. Triangle G-unit 16. Good, so we have that. And then unit 16 down here somewhere. In the setup where I cannot find it. Mesh data, set index, set vertex, set index buffer params. Yeah, this can be a 16. Doesn't need to be a 32. And then the triangles equal a U short. Type get index data and reinterpret as triangle units, please. Triangle U integer 16. Also, we only need 2 of them now. Half the size, right? Good. 16-bit indices. They say we have now. Is this real? Let's find out. Bum, ba-da-bum. Vertices 4, 192 bytes. Indices 6, in GUnit 16 format, 12 bytes. And we have one submesh. And how does it look here? This is exactly what we have. Good. That's very nice. Multiple vertex streams. Oh, jeez, what? As an example of a different iMesh streams implementation, let's include a multi-stream approach, like advanced multi-stream procedural mesh. Duplicate single stream and rename it to multi-stream. Replace it single stream and full streams. Yes. Definitely. Good. Dum, bum, bum, ba-da-da-da. Multi stream. Bum, 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 bum. Good. So we're going to rename it to multi-stream. Replace it single stream with 4 streams for the individual vertex attributes. We will do this. Good. Also, we renamed it, man. Multi. Struct layout, native disable. Layout kind sequential, struct 0 stream, native disable container safety restrictions. Oh, he just disabled the safety restrictions here. Man. Good. So what do you want? A float 3, a float 4, and a float 2. That looks better. I like this very much. I like this way better. Good. Native array. Float 3. Native array. Float 4. Good. And native array float 2. Alright. Float 3 is going to be a stream 0 and is going to be a stream 1. That's where our information is hidden. Good. And here we're going to put it in the stream number 2. Oh, wait a minute. What am I doing? This is the naming of the streams. Good. And here as well. Stream 3. Good. And then we will put it in the setup. Good. We have 3 dimensions here. Good. So that goes into stream 1. Wait. Separate it. It goes into stream number 1. Then we got 4 dimensions here. Goes into stream number 2. Why is this? Let's not worry about it. 2 dimensions go into stream 3. Good, and then descriptor 3 new vertex attribute text coordinate dimension into the stream new vertex descriptor vertex attribute descriptor. Yeah, I don't know what that is said. I didn't really get, but it's alright. Mesh data, set vertex buffer params, descriptor, sure. Then we have a stream 0 down here somewhere. And this must be 1, 2, 3, 4 streams in total. Good. And then get the vertex data as a float 3. Good. Here as well. Here a 4. And there a 2. Not 32. Good. And then the parameters, the arguments here are probably where to put it. Get vertex, or where to get it from. Which stream to get it from. That's what I'm thinking. Good. Then the method implementation. Yes. Streams with the index. Before it's set vertex, if we want to set the vertex, we're going to set it here. Dun, 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 dun. That is in the method implementation. Set vertex. Oh. It's different now, right? Or is this in addition? It might be in addition. But it might not. Surely not. Surely this all must go. Stream 0. New stream 0. Yeah, surely this must go. Good. It's now possible to switch to a multi-stream approach by replacing single stream with multi-stream in procedural mesh, generate mesh. Is it? Is it really? Procedural mesh, generate mesh. Do I have iMesh streams open twice? No. Good. Where do we have the mesh job? In the mesh job? Square grid. Generate mesh. This is in generate mesh here somewhere. Good. Semicolon after a block. Multi-stream 55. Good. Cannot implicitly convert 43. Float 4 to float 3. We have a 3, we have a 3, we have a 4, we have a 2. It's probably there, the difference. Or do I have to tell them that? Different job now. But here it says we still have something. But it is a set triangle, isn't it? Maybe, maybe not. What if I just put it in? Hmm. 49. This is crazy. Vertex, vertex, bup, bup. And where is this? Procedural mesh, generate mesh. Procedural mesh, generate mesh. Generators. Mesh job. Job handle. Where's the generate mesh? This I don't like this spaghetti. This is extreme spaghetti. Why? Anyways, generate mesh. Procedural mesh. Can you take me there? Line 16. Generate mesh. Square grid. multi-stream. Good. Good. Block bodies, it doesn't work. No, 49. I still think this is correct. Still think this would be correct. But it will complain again. Semicolon after method in 55. And then it complains again. Cannot implicitly converge. I think I made a mistake up there somewhere. That can't be too much. Native array, float 3. Float 4, float 2. Stream 3, stream 2, stream 0, stream 1. Good. Descriptor 1, descriptor 2. Descriptor 1, is something missing? Oh, definitely. There's definitely something missing. 1, 2, and 3. No, there's nothing missing. Stream 1, stream 2, stream 3. Dimension 243. Descriptor new vertex. Variable descriptor. Good. 3 nothing, float 3 nothing, float 4, float 2. 3, 3, 2, 1. This is all right now. Vertex, vertex. Position on vertex coordinates. Stream index. Good, multi-stream. Maybe we have to continue on. Note that it only knows about the generic vertex, completely how the vertex gets stored. Even possible that only part of the data gets stored. For example, we didn't know when judge burst will optimize away the unneeded code. Grid of quads. Now they have a functional framework. Don't really have a functional framework because it's not functioning. Ugh, what did we miss? (43, 44, 46, 40, 57). Name triangles does not exist in 46. Maybe we deleted too much? Maybe we don't need the triangles? Method implementation. Triangles. U short. Reinterpret. This is supposed to be there. Maybe I deleted too much up there. No doubt. Alright, no problem. To do everything again. Good. Multi-stream. iMesh stream. Good. Structural layout. Surely we don't need the structural layout anymore. So that was correct in deleting. Good. How are we looking now? Stream 0 cannot be found. That's fair. Good. Safety restriction. Native array float 3. Stream 0. Stream 1. Good. Oh yeah. Alright. Then we have a float 4. And we're gonna give it the stream 2. Dun, 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 dun. Then we have a float 2 lastly for the stream 3. Good, then we have the rest. Syntax error, comma expected. In the 14. What? Da, da. Good, tap on the next stream could have found. So you cannot press the command type your regulation mathematics float 3. Triangles does not exist. So there already we get this stuff. Maybe we missed something from before. But we got this native array triangles on top of the setup. We got this. Did we put it in the wrong setup? Because I don't see it here. Oh, no doubt we put this in the wrong setup. Okay, so I did not do this, I think. Or I did it somewhere else. Triangles equals. Triangles equals. Where's a single stream? Triangles equals. That we did. Good. Mesh data, set index. Set vertex, set index, index count, EU16. Here we did it, but we don't have the triangles. They're missing. How did this work then? Could we delete everything on top? And then below we have the triangles. Good. Streams in. Single stream. Native array triangles. Did this here before. Native array triangles. Here it is. Oh, did I delete too much? I think I just deleted too much. In the multi-stream. Native array stream 0, stream 0. We don't have either. But we're supposed to delete that one, I think. Native array stream 0. Yep, we're supposed to delete this. Ah, but not the triangle one. Alright, alright. Sure. Good. Triangles? We have... Now we have these things. And now we have to do that again. Descriptor 1. Good. Stream colon 1. Good, and we're going to have this on the 2. And we're going to have that on the 3. Then we have a bunch of floats here. Good. Stream 0. Oh yeah. Get vertex data, and this is not the stream 0. This is the float 3. Good, then we have a bunch of float 3 here, 4, 2, and 3. And then the triangles data. And then we have this again. I'm completely unsure. Set vertex. Let's save this and see what error it throws. Type of namespace stream 0 could not be found. Line 50. But we're going to get rid of this now, aren't we? Good. How about now? Dum bum bum bum. Good. Da 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 da. It's not possible to search multi-stream. We did this. Note that the generator only knows about the generator. It's simply obvious of quads. When we have function frame, we move on to generic mesh because of multiple quads, placed so that they form a regular square grid. Such a grid itself doesn't provide any benefit compared to a single quad, but it can be used as a basis of more complex meshes that aren't entirely flat. In this tutorial, we'll limit ourselves to a simple grid. Alright. But, does this do something now? Let's proc here. Oh, it procs already? Good. That's alright. Good. We'll adapt our code so it can produce a grid of R and R squares, where R stands for the resolution of the grid. The resolution of the mesh is a general concept, for which we can add a property to iMeshGenerator. In this case, the property should be settable, which we enforce by also including set in its block. iMeshGenerator. Good. Int resolution. Get set. Bounce, bounce. Resolution get set. We can implement this property in square grid. Where's my square grid? By including the same line of code. Seems dry. Only adding the public access modifier. This generates a trivial automatic property, which implicitly includes a field used by the property. I don't know what any of that means. No clue. Just want to learn here. Let's put it in. Good. The vertex count, index count, and job length now depend on the resolution. Is that so? The amount of quads is equal to the resolution squared. So we they have to be multiplied all by the public in vertex count 4 times the solution times the solution. Sure. Why not? Times the solution times the solution. And the job length is simply the resolution times the resolution. Add a resolution parameter to mesh job, schedule parallel, and use it to set the generator's resolution immediately after creating the job. Job handle schedule parallel. Job handle schedule parallel. Generators mesh job. Job handle schedule parallel. Mesh data int resolution. Good. Mesh data. Good. Immediately after creating the job. Sure. Good. And then job generator resolution equals resolution. Job generator vertex count. New mesh job. Under the new mesh job. Job generator resolution. Resolution to upstream, solid mesh. Oof. Good. Then add a resolution slider. Oh, I like the sound of that. To a procedural mesh and use it when generating the mesh. The minimum should be 1 and I'll use 10 for the maximum. Good. Now we're talking. Now the magic happens. Procedural mesh. We'll find it here somewhere. There's no argument given. Procedural mesh, but where is it? You can simply double click. Okay, there's no argument given. Let's give it an argument. Serialize field. Good. Serialize a field. Oh, what the heck is this? Serialize the field. Void generate mesh. Oh, is this here? In the class? Of course. Good. Int resolution 1, sure. Then we generate the mesh, but we will have a resolution definitely behind the mesh data. Square grid multi-stream here. Good. To support regenerating the mesh when we change the resolution while in play mode, yes! We have to make some more changes. Our approach this time is to include an update method that generates the mesh and then disables the component. Display update isn't needlessly invoked every frame. This is crazy pants. We enable the component in a new onValidate method. This means that we no longer need to generate the mesh in awake. Sweet. Let's see if it throws an error now. Just, nope. Is the slider there already? Just checking. Procedural mesh? There it is. Freaking yeah. Does it work now? No. Good, just checking. No problem. Good, just over resolution on awake, isn't we have awake here. We do not generate the mesh here on awake. Good, but we have a new method on validate, and there's a shorthand for the brackets, and this is a return. It returns a boolean. On validate returns a boolean by default. Did not know that. Or I don't know. Good, awake is done before we generate a mesh. We have on validate, and we have an update method, brand new. Good. Enabled false on validate. This is so cool. I do like this. I will learn from this 100%. After doing the tutorial, I will be a bit smarter. Not much, but a little bit. Resolution slider. Good. Good. Can we get rid of this? Now, will this work? So validating here. Nope, we're out of bounds. But it just shows the slider. Here. To make sure that we set the data for all quads, we'll determine the correct vertex and triangle indices at the start of execute. The job index passed to execute represents the quad index. So its first vertex index is the quadruple that, and its first triangle index is double that. Of course it is. Where is this now? At the start of execute. Where the heck is execute? Let's find it. Gold. Execute. Good. Two grids in one file. This is probably a square grid, in the square grid. Execute in the square grid, alright. Generating all quads. Square grid CS, which dimension, resolution, index count. Set vertex. And the job index passed to execute represents the quad index. Good. Int v equals 4, t equals 2. What the heck? iMesh streams. So this is before we even started out. We have these guys. We find the other vertices, indices, by adding an offset to the first one. I include the 0 offset for clarity, even though it does not affect the code. That's fair, I suppose. Good. Streams set vertex. Good. V plus 1. Stream set vertex. V plus 2 and V plus 3. Same goes for the triangles. In this case, we also have to add the first vertex index to the relative vertex indices that define the triangles to keep them relative. Of course. Why even mention? Set triangle. Good. Bomb, beam, bomb. V plus again. Wait, this is... Oh no, this is V, this is T. Plus the end. Good. What else? We also have to determine the position offsets for the quads relative to their bottom left corners. We find the y offset via an integer division of the quad index by the resolution. The x offset is then found by subtracting y times the resolution from the quad index. Good. So this goes on top. Alright. We can define all 4 coordinates that we need for the quad in a single float 4 value, containing x, x plus 1, y, and y plus 1. But we'll initially only add 0.9 to leave a visible gap between the quads. Good coordinates. Let's put in some coordinates. Clearly this is a float 4. So we don't need here to say float 4 double times. We can set the positions correctly via swizzle operations on the coordinates, selecting the appropriate 2 coordinates per position. Yes. Good. Vertex position xy coordinates. Stream set vertex 0 here. And the xy, xz, xw, yw. Ugh. Brutal. Good. Coordinates. Vertex position. Alright. So we replace the right, we replace the up, and we will also replace this float 3 here. Good. Alright. And now we should have this here, resolution 2 grid with gaps. Dun, boom. But we don't, because we don't have a slider. Ah! More! Ah! More! Ah! Now we're talking. Now we're talking. Let's add a component here. A rigid body. Oh, where is it going? Alright. Good, now. Plane. Grids are typically used for flat planes, so let's adjust ours. But it's really hot. I'm going to cut it out here and continue on another time. Good. Because I also want to do the other voxel tutorial from the Indian guy and see how he's doing it. Good, so let this be it for the moment. We're definitely going to come back to this. It's brutally fun, and even though we don't really understand what is going on, it does make sense completely. And all this stuff here, the different folders and the inheritances, and making structs, and here having just a vertex CS and then putting the other vertex CX vertex type into a namespace, and all this I'm sure makes complete sense because I trust this guy here, the Catlike. He definitely knows what he's doing. First time I was following the Bezier curves tutorial and it was really good, and I can only recommend the Bezier tutorial because then you learn how to do a Unity editor script, and that is also quite useful. But yeah, until next time, which will be very soon. Tonight is going to be time for the Warhammer 40k. Hope to see you there. Until then, have a good day and a good night.